Okay, so shall we start? So let me introduce myself first, okay, because I am Dr. Narendra Kumar, and I am working here as an assistant professor since 2019, and my research area basically is 3D printing, or you might be known as this technology as additive manufacturing, right? And I am doing various projects with ISRO and SERB, and recently I have received 2 projects from BIS only, right? So today I will be talking about the additive manufacturing of composites. So here, because I have chosen this topic for this lecture particularly, because the theme of this workshop is modern composite material, right, and manufacturing. So nowadays additive manufacturing is becoming very popular for composite manufacturing, right? Because I think in the previous lecture, Professor has discussed about the different manufacturing techniques, where he has already covered the filament binding and other techniques, but he has not covered about the additive manufacturing. So I will try to give you brief idea how can you use this particular technology for composite preparations, and if you choose this technology, what are the advantages, right? What kind of failures you may face during the preparation, and what kind of challenges may be there, and how can you overcome with those challenges. Okay, so I will try to cover those aspects. So this is my brief outline. So initially I will be giving the idea of additive manufacturing, and then I will be talking about the composites in additive manufacturing and types of additive manufacturing. Then finally I will move to the polymer composite developments using different additive manufacturing processes. So my lecture would be means more focused on the polymer composites only, because here I have only 1 hour, right? So if I cover polymer matrix based composite, ceramic matrix based composite, then it needs a lot of time. So I will try to cover all the aspects related to the polymer composites through additive manufacturing, right? So if you find any difficulty or any if you have any query, then you can ask after my lecture, right? Okay, so let me ask one question first. What is additive manufacturing? Do you have any idea? Because I can see here Vishal is doing PhD in additive manufacturing, so he has idea about this. But anyone other than the Vishal and his friend, anyone? What is additive manufacturing? Have you ever heard about this technology? No? 3D printing? I think all of you, because nowadays it is very popular, and I think all the institutes nowadays have this particular technology in their labs, right? So additive manufacturing, sir, you can change your seat, otherwise it will block the view. So it is a process of making the objects, 3D objects, but in layer by layer manner. We add material at a time, only single layer deposited, then we add material, another layer of the material, then another layer of the material, and we add the layers until the whole part fabrication is achieved or completed, right? Now the question is how it is different from the conventional manufacturing like subtractive manufacturing. If I talk about the conventional manufacturing, I think most of the techniques are based on the subtractive manufacturing. If you take the example of injection molding, for mold making we need to use machining, we need to use milling process, right? So milling means we need to remove material from the large stock, right, to get the desired shape. But here the idea is different. In this slide you can see that initially we take material either in the powder form or in the filament form or in the liquid form, right, and then we feed that material in the machine, and then finally we achieve this 3D object, right? However, if I talk about the conventional manufacturing, here we take large size of material or the stock, and then we remove material in the form of chips right? So these are the chips, this is the waste material, and this is the desired geometry that we have achieved through this machining, conventional machining process, right? So this is the difference. If you compare these two, you will find the difference in the waste, right? Another difference that I will share, I will discuss in the next slides. Okay, so this is a basic difference that you can just have idea. Okay, so what is the history of additive manufacturing? So it was started late means in 1980s. So the first process was stereolithography, right? Stereolithography, that was the first 3D printing or the additive manufacturing process. And then selective layer sintering was also started that time. And in 90s, filament deposition modeling or fused deposition modeling process came into the existence. Okay, so this was developed by Stratasys company. Stratasys basically was the inventor, okay, or that company who invented this particular technology, and this technology was filament based technology where we can use any kind of thermoplastic in the filament form. So, and then after 2007, when the patent was expired, okay, all patents related to the 3D printing were expired. That time, many companies launched their printers on the same technologies, right? Whether it is FDM, whether it is SLS, whether it is SLA. Nowadays, one printer DLP is very popular. If you, I don't know whether you know about that or not. Along with FDM, okay, DLP is also becoming popular, and you can get this SLA. Basically, DLP is nothing but the similar to SLA, stereolithography, right? So DLP you can get only for 20,000 rupees. FDM you can get only for 15,000 rupees, 18,000 rupees, right? So DLP is becoming popular because of its cost, because it's equivalent to the FDM process. Suppose you want to purchase new machines, or you don't have money, you have only 50,000 rupees, you can purchase both the machines. You can purchase FDM as well as DLP. DLP is digital light processing. It is very similar to the SLA. SLA, I will discuss, right? Then other companies entered. Then nowadays you can see this 3D printing now a $1 billion industry. $1 billion industry nowadays. People are having startup based on services. They are providing services. You just go there and you supply your STL file. They will print for you, right? You just discuss your idea or your problem with the industries. They will solve through 3D printing, right? So this is the history. Now this technology is basically it's in the matured stage. More materials have entered, right? Or new machines are coming. They have more speed features, because earlier speed was the issue. Suppose I want to make a small cube, it will take around 2 hours. But now new machines are there, they will take only 15 minutes. They have changed hardware completely. I have also released one PO for new machine that has very good speed and very good features. Those were not available in my previous machines. So it means new manufacturers, new companies are focusing on this technology, and they are coming up with new 3D printers with some novel features. Even some of them have incorporated AI camera. So camera will capture the the current movements. If any problem there, printer will be stopped automatically. So those features actually nowadays are available with printers, right? Now, why we are talking about the additive manufacturing of composites? What is the reason? So here I have mentioned few reasons like customization, and second one is the rapid prototyping and iterative design, and third is very most important, that is the complex geometries and design. Complex geometry or customization, because 3D printing or additive manufacturing offers the printing or the manufacturing of the objects with customization. because here there is no requirement of tool, right? No requirement of mold, right? So just what we need only CAD model. If you have CAD model, if you have STL file, you can directly feed that file into 3D printing machine, and 3D printing machine will read your file, the program which you have loaded, and it will start automatically depositing material. So complexity is not a big deal nowadays, but this complexity is very difficult to achieve through conventional manufacturing. For example, if I want to make a complex object, right, through injection molding machine or the compressor molding machine, in that case what I need to do? I need to make the mold first. So for that complex object, mold making itself is a challenging task, very challenging, because we need to write the program, right? We need to design the fixture, we need to think about the tools that will be used to make that complex mold, and it will take a lot of time, right? And lot of energy will be involved there if you go through the conventional manufacturing. But when you opt additive manufacturing, it provides the flexibility. You can make your own part with customized features. Second thing, complexity. So complexity is not an issue nowadays. I'm not claiming that any complexity can be achieved. No, this is also not true. If you say, sir, can we make this? We have to assess the features of the 3D printing machine that is available with you. Then only we can say that this complexity can be achieved with the available machine. Otherwise, we cannot claim that any complexity can be achieved by FDM, or this complexity can be achieved by SLS printer or SLA printer. So whenever you are planning to make a complex object, first of all, you need to check the machine. What machine you have with you, right? What machine do you have? And you assess all the features, specifications of the machine. Then only you just go for the geometry development or the CAD model development. Otherwise, what will happen? Suppose you have given one feature in your CAD model, right? And when you convert your model into STL file, right? Then you will feed that STL file into the software. That software will generate the program. But when you load that program on the machine, that feature may be missing or may be missed by the machine. That will not be available in the final part or final printed part. Why? Because of that machine is not having that much capability. That fine feature may be missed by the machine. So whenever you are going to use any additive manufacturing system for the printing, in that case, first you need to check the machine parameters, right? What is the minimum size that can be achieved with the machine, right? What are the other parameters? Accordingly, you should go for the CAD modeling. Otherwise, consequences may be different, right? So this is the this slide highlights the importance of additive manufacturing in modern manufacturing. Okay, and here we can reduce some material waste that I have already shown you, and this thing is also very important. Simplified supply chains. How? Simplified supply chains. Ajay, do you know about the NASA refabricator? NASA refabricator. Have you ever heard about this term, NASA refabricator? Acha, how many of you know about International Space Station? International Space Station. I think everybody knows. Suppose they want a nut and bolt, right? They want nut and bolt to assemble two components. What they will do? They will order to NASA, then NASA will arrange rocket and they will send that nut and bolt to ISS. This is as per the conventional supply chain, right? If suppose if I talk about the conventional supply chain, what I will do? I will talk to NASA scientist, right? Then I will tell about my requirement. I need nut and bolt to assemble these two components. Now what NASA will do? NASA will arrange a rocket, right? And they will load those components on the rocket, and then rocket will go to the ISS. So what is the cost? It is too much, right? We cannot imagine. But NASA, what NASA has done actually? They made a printer. The printer name is NASA Refabricator. Okay. So they have sent that printer on the ISS, or they deployed that printer on the ISS. So now what they do? If they want any small item, right, or anything for assembly or for some other purpose, they print those components or those parts there itself. So that's why I am saying simplified supply chain. So this thing will be replicated here also, because now we are moving toward the industry 4.0. Okay. So small or localized 3D printing centers will be established across the country, similar to EV, because EV nowadays electrical vehicles are getting popularity. Now what will happen in the future? Similar to the petrol means filling stations, we will have the charging stations, right? So in the industry 4.0, in the coming future, in the coming 10 or 20 years, we will have the 3D printing hubs. In Jalandhar there will be one 3D printing hub. In Panipat we will have one 3D printing hub. In Chandigarh we will have one 3D printing hub, right? So this will disrupt the existing supply chain of the materials because of the capabilities. Because when you will have the facility, obviously you will demand for the customized products, right? So now no need to go to or to visit the shops. You will directly go to the 3D printing hubs. Okay, they will make the shoes for you. They will make the customized items for you, right? So it will simplify the chain. So that's why it's very important to understand about additive manufacturing and the additive manufacturing of composites through, okay, because this is important topic, because I have got funding based on the composites only. Because when I was writing proposal, right, when I was planning to submit a proposal, I thought what should I do, on what topic I can write a proposal. So one proposal that was clear, because ISRO has mentioned the topic, you have to submit only on this topic, right? But when I was submitting a project to DST SERV, that time I just prepared my proposal on the high performance polymer composites, and surprisingly I got funding of 55 lakh rupees. So why government actually investing money on this area? Because this is important, right? If you write a proposal on handley technique, you will not receive funding, because that is conventional one. So if you come up with new idea or new manufacturing technique, obviously you will get funding also, you will get PhD also, you will get MTech, you will get everything. Okay. So this is the importance of additive manufacturing in the modern manufacturing era. And here I have highlighted the advantages of additive manufacturing for composite parts. So it provides flexibility in the design. Vivek, can you give me that box? Okay, here. Sorry. It is the, yeah, like this is the honeycomb structure, right? This one. So I can make any structure, I can design my own part, right? So that's why first one is the design flexibility. So I can design my part. Long back actually, today I found these parts in my office. So I thought I should show you. During my PhD, what I did, I made lot of things. So this is customized keychain, and on the center, if you look at the center, right, in Hindi I have written Narendra. Okay, and my lab name actually has been printed in the center, and on the outer periphery I have written my college name. So design flexibility, right? First advantage is the design flexibility. I can design my own part. It gives flexibility to the user. They can come up with new ideas, new designs. So this is one of the advantages. Second is the lightweight design. So lightweight means this is lightweight. I can plan how I will put lightweight feature in the components. So I can use honeycomb structure. I can use any other pattern also. So lightweight feature is there. Okay. Otherwise, what we do when we make composite, we try to find the lightweight reinforcement filler material, right? We look forward toward that direction, na? But here, material wise, you can make it lightweight, and also design wise, based on the design, you can make the parts lighter. There are two things, and this reduce lead time. Is it true? Can we reduce lead time? How? Yes, because tooling is not there, right? Tooling requirements are not there. We are not making any mold. Otherwise, in the conventional manufacturing, what we do? First we make mold. So it takes time, 2 days, 3 days, 4 days. But in 3D printing, no tooling is required, no mold is required. So obviously, it will reduce the lead time. And fourth one is the on-demand production. No need to store inventory. Suppose today I got the offer. Suppose today I get the order from the industry. Okay, please make this part for us. What I will do? I will just prepare STL file and then directly feed that STL file into 3D printer, and 3D printer will develop the part for me, and then immediately I will supply that part to the industry. So no need to maintain the inventory. So this is one of the feature or advantage with EM. So mechanical properties of AM composite parts: we can increase strength, we can also reduce the weight, as I already discussed with you, right? Okay, what kind of applications we can target through additive manufacturing? Here I mentioned especially 4 industries. First one is the aerospace industry, second one is automotive industry, and third one is medical devices, and final one is the energy sector. So in the aerospace, what we can do, we can create or we can develop strong and lightweight components, right? Strong and lightweight components. So this, with 3D printing we can achieve this. Or we can use the 3D printed components in aerospace industry, because as I told you, 3D printing provides, or additive manufacturing provides, the design flexibility. So by design also you can provide you can reduce the weight, okay, and by just making some new composite you can reduce the weight of the overall weight of the component, right? Then automotive, similarly engine components, suspension parts, body panels, here also similar kind of requirements, okay, as we had in the case of aerospace. So here also we can improve the fuel efficiency. And third is medical device. I think this is one of the sector which has been benefited with this technology most. Medical industry. How? One of my friend who is based in Nagpur, what he does, he supply temporal bones, models of temporal bone, complex, not implants basically, temporal bones for surgical simulation. What is surgical simulation? Before surgery, doctor want training, okay, or we need to give training to the doctor. So this 3D printed components or this 3D printed bone can be used for that purpose also. Implant is also one of the application, but this area has huge potential. You can use the components for surgical simulation. You can use the components for as a implant also, right? Case to case basis, the application of 3D printed parts may vary, but he is getting he is earning money by using 3D printing, right? And he is doing very good in this area. And what he has developed composite also, because earlier what was happening, he was using ABS only to develop the temporal bone. So when doctor was taking training on the ABS material, right? So that time haptic feedback was different. Force, every parameter was different. So when they were, for example, suppose they wanted to do drilling on the temporal bone or actual bone, that time the feedback will be different because there is a difference between the material. Because bone is having different properties, right? And ABS has different property. So that is why what he did, he developed a new material, right, by doing R&D, and he come up with new material that has the bone like properties. Now again the same thing they are doing, again they are giving training to the doctors. Now they have more or less equivalent kind of feedback when they are drilling or they are doing something with those bones. So accuracy of the doctors will be increased. So in this way also we can train the doctors. Next is energy. So energy means wind turbine blades. The design is very important parameter, right? So you can design the blades, you can increase airflow or you can increase output. So those things can be done. And this heat exchanger is one of the area. I think most of the people are exploring this area with the additive manufacturing. One of my PhD has also done research in this area where we have made the polymer based heat exchangers, and we published articles on this particular topic, right? So what are the different materials that can be used in the AM composite printing? So reinforcement materials like carbon fibers, glass fibers and other fibers can also be used. Another matrix material, we can use the polymeric materials like EBS, PLA, PEEK and epoxy resins can be used also, right? Properties that are relevant to the additive manufacturing. So here the mechanical properties like high strength to weight ratio, flexibility in the load bearing. Flexibility in the load bearing means we can align the fiber, we can orient the fibers along the load direction, right? We can change this because we have the nozzle or the mechanism by which we can control the orientation of the fiber. Like in the case of continuous fiber 3D printing, I will tell you later on. So flexibility in load bearing, impact resistance, thermal resistance, in which we can just increase the heat resistance, right? So that your composite will withstand at high temperatures, and thermal insulation, electrical properties. So conductivity, I think you can work on conductive materials. You can increase conductivity by adding some fillers like graphene and CNT. Insulation. So these are some of the properties that are generally increased, or you can say the most of the materials are developed to increase these properties, okay, case to case basis. Some of them may focus on the durability of the composites. One of my PhD scholar actually is working in this area where we are trying to increase the durability because if you know about 3D printing, you know PLA is most popular material, right? PLA, but still its durability is unknown. Suppose I make a component using PLA, but what is its durability, for how much time I can use it, that is still unknown. 2 year, 3 year, 2 year, or 5 year, or 10 year. So what we are doing, we are exposing the PLA components in different environment, right? And then we are checking their performance under UV, under salt spray, right? So a lot of conditions we are virtually creating through the apparatus, and then we are checking their performance. So this is also one of the area for property. Customized property, nowadays graded properties also there, gradual variation you can achieve. This is I think one of the most hot topic, or you can say this is one of the area that can be achieved, or that can be done through 3D printing only. Gradual variation, layer by layer variation we can provide, okay, through 3D printing only. By using injection molding, by using any other process, you cannot do it. But with 3D printing, this is possible. Gradual variation in the composition can be achieved. So this is I think one of the area that is very popular now. Functionally graded structures. Functionally graded structures, right? FGS or FGM, a material. So this is I think very new area where people are working. So common composite materials in AM. So carbon fiber reinforced polymers, carbon fiber reinforced, glass fiber are there. Nano composites, some hybrid composites are also there in this field. And this is the emerging area where you can develop some bio-based composites. Smart composites. Smart composite means smart composite with embedded sensors. So this we have printed in our lab. This one, right? So this is epoxy, and we have 3 layers in this, and lower layer and upper layer we have used epoxy, but inside between the epoxy layers we have also deposited copper material, right? This is also one of the area. If you go through conventional method, so for through conventional method you have to go for etching, right? Lot of processes or steps are involved, but with 3D printing we can easily achieve. So this is also one of the area that you can explore. And so now here I have categorized the additive manufacturing based on the material type or the matrix type. So in the first category I have mentioned polymer matrix based additive manufacturing. Second is the ceramic based, and third is the metal based, right? So 3 categories we have taken here. So in the polymer, where we can make polymer matrix based composite, so here we have FDM, we have SLA, we have SLS, we have direct ink writing, and in the second category we have binder jetting. This direct ink writing can be used here also and here also, right? And this process also can be used here, okay? And then metal based, powder bed fusion, direct energy deposition. So I am not going to cover in detail this technology. So what is FDM for composites? So those people who do not have any idea about FDM, so let me cover the working principle of this technology first, then we will move to the other slides. So here if you look at this schematic diagram, here what we have this build platform, right? And we have the this build platform, we have 2 spools, right? And here we have this extrusion head. So we are supplying material in the filament form and it is going toward the extrusion head, and here we have heating mechanism, right? So due to this heating mechanism, the temperature of the material is increased up to 200 degrees centigrade or 220 degrees centigrade. Then it is deposited on this plate form, right? So initially we deposit material and form first layer, then second layer, third layer, fourth layer, right, up to 1000 or up to 2000 layers, okay, depending on the height of the specimen, okay. So this is the principle. Now suppose I want to make a composite material for this particular process, what steps I need to follow? So first is initially I will select my matrix material. It may be PLA, it may be ABS, it may be nylon, it may be PETG, right? And then I will select my reinforced material also, right? Then in order to mix both the materials, matrix material and the reinforcement, what I will do, I can go for melt mixing directly, or else I can go for the solution based mixing, solvent based mixing. Melt mixing means here I can use twin screw extruder. I will directly feed my reinforcement and the matrix material into the hopper, and then I will just rotate the screw, and where we have the heating arrangement similar to the FDM, and then material will be mixed through the melting only. But in the solution based mixing, what we do, initially we take the solvent, right, and that is selected based on the selected matrix material. Suppose matrix material is ABS, for example. So acetone is the solvent of the ABS. So I will take ABS and acetone both, and then I will use magnetic stirrer, or I can go for the ultrasonic stirrer also. So I will mix, I will prepare the solution. Then after I will add the reinforcement material. Then again I will mix it. So after means ensuring the mixing, I will dry the composite, okay, and I will just pour the material on the flat sheet, and then I can keep it in the furnace. So solvent will be evaporated, and after that, after ensuring the dryness, I will cut the material into the small pieces, or I can convert them into the small pellets pieces. Then I will feed it into the filament maker, okay. So filament maker, when we feed that material in the filament maker, that will give us the filament. But filament, see here I have mentioned the size of the filament. 1 point, we have to ensure the diameter 1.75 mm. Okay, plus minus some tolerance may be given, but usually we try to make, or we try to achieve this diameter in the filaments. Then only we will be able to feed the filament into 3D printers, right? Now, so printing considerations, when you are planning to make a composite for FDM, then yes. Printing consideration means here we need to ensure the printer nozzle is suitable for the composite that is under consideration or not. Why? Because suppose you are just going to add the hard material, okay, that hardness is greater than the nozzle material. In that case, what will happen? It will wear out. The nozzle will wear out, right? The size of the nozzle will be changed. So you need to check this first, okay? So in that case, you can use good material nozzles, stainless steel nozzle or other materials are also available. So you can check the compatibility of nozzle with that composite, and then you need to optimize the settings, printing settings, like parameter, temperature, bed temperature, okay, speed, that you have to be you need to optimize them. Otherwise what will happen, you will not be able to achieve the proper flow rate, proper adhesion. For example, I have added something in the PLA, right? Usually I print PLA at 200 degree centigrade, but when I add some filler material, add some reinforcement, it will change the property, because we have ensured the proper dispersion of reinforcement into the PLA matrix. So in that case, I have to either decrease the temperature or increase the temperature, because in one of my case recently, because my scholar he is trying to develop a filament of PLA and ZNO, right? So when we are mixing it with ZNO, we are not able to convert that composite into filament form. It is increasing the flow of PLA, and I have consulted about this with the CPAT Bhubaneswar. Even they are not able to make the filament. So sometimes these issues actually might be there. So be ready for these kind of challenges. Now we are finding different way how to tackle that issue. So that is why suddenly means the property of the matrix may be changed, okay, due to the addition of the reinforcement. So this is, I think, the very important thing that you need to consider. And drying is also very important, because composite filaments sometimes may absorb the moisture. So ensure or dry them before printing to prevent any defect. And sometimes you need to do the post processing, surface finishing, right? Thermal treatment, sometimes it may be required. So I'm not going to cover in detail because of the time. Oh, quickly I will finish because of the time. Okay, so key challenges: dispersion of the reinforcement is very important parameter. So poor dispersion can lead to the weak spot or the defects within the developed composite, right? It may create the holes, right? It may reduce the strength of the material, flexibility, elongation at break, the value may be decreased. So you need to mix the reinforcement and matrix properly by using some good mixing mechanisms. So ultrasonic mixture can be used for this purpose. Nozzle wear, you need to take care about this because we have already discussed. Printability, you need to adjust the parameters, okay, thickness, height, support, to avoid the clogging or to achieve the desired mechanical properties. Okay, next process is the SLA for composites. SLA for composites. So SLA is stereolithography. It is liquid based process. Resin, here we use the special resin that is cured under UV light. No heating mechanism is involved in this case. Here just we use a material. When we expose that material under UV light, it is solidified. Okay. So here this is under this also, because the material form is resin. So you can take the resin first, then you can take the reinforcement material, then you need to do mixing, right? And then after sometimes you need to add some photoinitial adjustment because it may affect the curable feature of the material, right? Suppose before mixing the curing time was less, for example, but after mixing the reinforcement in the resin, curing time may be increased or decreased depending on the material that you mix in the resin. So you need to adjust this particular value So you can add photo initiator to ensure the proper solidification. Light penetration, because it is, as I told you, no heating mechanism is involved in this particular process. So here we are dealing with UV light, right? So here I mentioned one point, reinforcements like opaque particles, they can block the UV light. So if they block UV light, what will happen? That portion will remain in the liquid form. So obviously the desired geometry will not be misprinted, right? So this is one of the problem. So okay, I will provide these slides so you can go through them. Yes, one key challenge is there, that is the sedimentation. Due to gravity, because here we use a tank, and when suppose you have prepared the composite by just taking the resin and the reinforcement, but after a certain period of time, right, what will happen? The reinforcement fillers may be settled down on the base. So on the upper portion you will have the the different dispersion, and on the at the bottom high dense dispersion of the these filler particles may be available. Okay, so it will change the properties. Is it clear? So sedimentation is one of the key problem or key challenge when you go for the composite development through SLA, right? Second is light scattering, right? So here what we can do, we can reduce the particle size, or we can use the transparent reinforcement to minimize the UV scattering. Another process that is also the liquid based process. So this is direct ink writing, right? So this process we have also developed in our lab, and the part that I have shown to you, that copper and the epoxy printed component, that we have made through this technique only, direct ink writing. So direct ink writing means here we prepare ink or resin, we prepare the resin in the ink form, then with the help of syringe we just deposit the material on the plate form. So here two mechanisms generally are used. One is the heating mechanism, thermal based curing systems, sometimes that may be used, and second is the UV curing based mechanism. We can use UV light, okay, on from the top we can just throw UV light on the material which is coming out from the nozzle, okay, in order to solidify that, or in order to ensure the solidification. So here similarly we have the matrix based ink, so any ink material that you can choose, and other matrices like conductive polymers, or you can use conductive material like copper, aluminum ink, and other inks which are available in the market. So you may select, and then fibers you can add. So depending on your requirement you can select the matrix material and reinforcement material, and initially same thing that we have done in the previous case, mixing, and then after you can add some other agents to ensure the thickness or the viscosity, because we need to extrude the material through a small nozzle is needle basically, right? So you have to ensure the viscosity. If it is too viscous, you want to be able to extrude it. If it is too means in the liquid form, it will flow, it will be flown on the surface, right? It will be spreaded immediately after coming out from the nozzle, right? So that is why it is very important to control its rheology. So you can control it by using the plasticizer, thickener, so they are available. Viscosity, stability, right? Loading the ink nozzle, this is the these are the steps. So post processing sometimes required, further curing is required. We can keep the samples in the UV furnace, okay, and then cleaning, surface finishing. So key challenge is rheological balance. When you when you are adding reinforcement particle in the resin, so balance in the rheology is very important. And sedimentation, again the same problem that was available with SLA, okay. Nozzle clogging, because here we are depositing material from the nozzle and nozzle diameter is very small. So in our case, what is the size of nozzle, Vivek? 0.1 mm? 0.1 mm. So 0.1 mm is very small. Suppose the filler particles are agglomerated, right, inside the resin. So their gross size may be increased, right. So they will block the, or they will clog the nozzle. So this is one of the issue. And then SLS, selective laser sintering. Here what we do, we use material in the powder form. So powder means from the top we just use the laser source, right. So laser beam actually moves along X and Y direction, right. Then sintering takes place, okay. And then platform is lowered down by the layer thickness, okay, equal to the layer thickness, and then again further powder particles are added with the help of recoater arm, and then again that same process is repeated until the whole part fabrication is completed. So here we use material in the powder form, so we can select polyamide, polyether ketone. I think PEEK nowadays PEEK is very hot topic, PEEK material, because it has capability to sustain at 400 degree centigrade, 300 to 400 degree centigrade, right, and it has lot of application in biomedical engineering. So people are processing this material in the pellet form also, in the powder form also, right, and in the filament form. I think very few printers are available in the market, right, those can handle this PEEK material. Otherwise ordinary printer cannot print this PEEK material, polyether ketone. So if you are planning to do some research, you can select the matrix of PEEK matrix. It will give you new dimension, okay. It will give you the idea, means you can publish lot of paper by taking this PEEK material, okay. So here mixing and blending technique can be used to just prepare the composite, right. So sometimes you can coat the powder particles, you can use all the melt blending also, right. Again you can convert this granulate, that you can granulate, again you can convert them into the powder form. So then particle size, flowability, thermal behavior optimization can be done. So key challenges are homogeneity, achieving even dispersion of the reinforcement in the powder matrix, right, powder flowability, laser energy absorption. So these are the challenges, okay, that may occur during the composite development through the SLS. So I'm going to skip this. Let me tell you these, yes, challenges and limitations of EM composites. So first challenge is scale up, because with injection molding machine we can produce component at mass level, but with this the process too slow. Initially you have to prepare the composite, then slowly it will make the component, right, by adding material in the layer form. So scale up is one of the issue. Second is material development, because we have seen when we are changing the process we have to change the way also. For powder based AM processes we need to use different process for composite preparation. For FDM, we are using different process for composite preparation, right? So material development is bit difficult, right? And it has limitation also. Then cost. So AM composites can still be more expensive than traditional composites. If I make any component by using the additive manufacturing, right, obviously it will be costly, because I will do reinforcement, I will fine tune the parameters, so it is a bit difficult, right? So I think these are the challenges and limitation in this area. And what are the future trends and innovations? Multi-material printing, multi-material, because currently if I talk about FDM, mostly dual nozzle printers are available, dual nozzle. Only we have two nozzles, two material can be used at a, means to make a part, right? Suppose I want to make print the base material by using PLA, I can do it. Upper portion I want to use, for upper portion I want to use ABS material, I can use the ABS. But nowadays what is happening, one company, that is Bamboo Lab, right? Bamboo Lab, what they are doing, they are selling their printer with this multi-printing feature. Multi-printing means only 4 materials. You cannot use material more than 4. 4 materials only can be used, right, to make a single part. So they are calling that printer is multi-material. But still, if you want to use more materials to make your part, again it is very difficult. FDM, similarly DIW, we have to increase the number of nozzle, it will increase the complexity. Similarly for SLS, because we have one platform where we are recoating powder and powder again and again. So how I will change the powder material for each layer? So processing of powder is very difficult, right? Because if I change the powder particle after 1 layer or 2 layer, 3 layer, so with SLS, multi-color printing or multi-material printing is not possible. Or if you modify the existing SLS, it will be very complex, or it may take a lot of time, right? So this is, I think, one of the area, multi-material printing. This can be the game changer, okay, in near future. If anybody comes with the new idea with multi-material printing, then I think this will get the market, okay. Automated design optimization. So in the coming time, AI and machine learning will be used to optimize the designs, right? जैसे मैंने आपको, because I have shown you one part, right? That honeycomb one. Where is it? Yeah, this one. This one. So here I have just used this honeycomb pattern for whole. I have applied this honeycomb pattern for this whole part, right? But if we apply AI based some mechanism, okay, so that will optimize the design. Where I need more strength, it will change the pattern. Where I need only less strength, it will change the pattern automatically. I need to give the shape only. I will feed the shape only. It will give me the optimized design of the component. Similarly, okay, increased production speed. Still speed is slow, because as I told you, if you make a small part, right, this much small, what will happen? It will take around 30 minutes or 1 hour, right? But with injection molding, machine will take only 1 second or 2 seconds. Okay, so this is still, I think, this is still one of the challenge, or this is one of the area where you can work on the production speed. You can try to increase the speed of the 3D printing systems by adding new motors, new mechanisms, new hardware, right? So this is all about the AM of composites, right? If you have any query, any suggestion, you are most welcome to us. Any